In this video, we're going to work through a fluids FRQ for AP Physics 1. In scenario 1, a swimmer holds a block of mass m at rest in a tank of fresh water with density ρ1, as shown in figure 1. The block is released from rest and accelerates upward with initial acceleration a1. All frictional forces are negligible. In scenario 2, the swimmer holds the same block at rest in a tank of salt water with density ρ2, where ρ2 is greater than ρ1. The swimmer again releases the block from rest and the block accelerates upward with initial acceleration a2. All frictional forces are negligible. Part A. Indicate whether a1 is greater than, less than, or equal to a2 by writing one of the following in your answer booklet. Justify your answer in terms of all forces exerted on the block in each scenario. Use qualitative reasoning beyond referencing equations. So the first thing we're going to do is to draw a force diagram. So we have gravitational force down and we have buoyant force going up. Now the mass of the block in both situations is the same, so the gravitational force is the same in both scenarios. However, the buoyant force is going to be different because the buoyant force is directly proportional to the density of the fluids displaced. The buoyant force in scenario 2 will be greater because the density of the liquid in scenario 2 is greater than in scenario 1. And we also know that acceleration is equal to net force divided by mass, and net force in this case is the buoyant force minus the gravitational force. And since scenario 2 has a greater buoyant force, it's going to have a greater net force, and therefore it will have a greater acceleration. So A2 is greater than A1, or we can say that A1 is less than A2. Part B. Consider the general case where a block of mass m and volume v is completely submerged in a fluid of density ρ. Starting with Newton's second law, derive an expression for the initial upward acceleration a of the block when the block is released from rest. Express your answer in terms of m, v, and ρ and physical constants as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference information. Once again, we're going to look at our force diagram. I'm going to make a positive, and we have gravity force down and buoyant force up. Acceleration is equal to the net force divided by mass, and net force is the buoyant force minus the gravitational force. If we substitute the equation for buoyant force, we get rho vg minus, and then the equation for gravitational force is mg. So we end up with rho vg minus mg divided by m. Part C. Indicate whether the expression for the acceleration a you derived in part B is or is not consistent with the claim made in part A. Briefly justify your answer by referencing your derivation in part B. So our equation that we derive, or our expression that we derived in part B, is consistent with our claim in part A because a greater density is going to increase the numerator up here, and a bigger numerator will result in a bigger acceleration.